Express this polynomial rational function in this form, where a and b are integers. Express this polynomial rational function in this form, where c and d are integers. Evaluate this integral, giving your answer in the form p plus log q, where p and q are rational numbers. Okay, that's the question. I've summarized it here. Because it's already written out in the form that we like, we can just equate coefficients, can't we? We can just let that equal and cross multiply. So here, let me just write down what I mean. Basically, if this is equal to that, then 2x plus 3 must equal, so I'm letting them equal one another here. And then I'm multiplying through by this, 4x squared minus 1, so it's going to be a 2x plus 1, because this is the product of these two, isn't it? So times by this, and just effectively cross multiplying, plus b 2x minus 1, that's what we've got there. So we can either equate coefficients or substitute convenient values. Put in x as a half then. There's a convenient value there. 2 halves of 1, 1 plus 3 is 4. 2 halves of 1, 1 plus 1 is 2. 2 halves of 1, 1 minus 1 is 0. That's why we substituted that value. So a here equals 2. 4 over 2 is 2. Now put the other value in. X is minus a half, and this will go to 0. Minus half is minus 1, plus 3 is 2. Minus half in here will make that go to 0. Minus half is minus 1, minus another 1 is minus 2 lots of b. So that tells us what b is. B is equal to minus 1, isn't it? Okay, so we've done that then, where a and b are integers. So answer then, we can write it out as equal to a over 2x minus 1 plus b, which is minus 1, over 2x plus 1. I'm just going to look at the form above. It's got a plus here, so I'm going to put a plus there and keep the minus 1 there. Okay, that's part A. Part B then. Let's have a look at this one. Now again, because it's already written out in this form, I'm just going to multiply through and put them as equals, and multiply through by the denominator all the way through. So here, this then, the numerator, must equal cx times the 4x squared minus 1 plus d 2x plus 3, and then we just times it all the way through, didn't we, when we let it equal each other. So that's what we've got then. So what should we equate then? Let's equate x cubes. That's the easiest thing to equate both sides. There's 12 on this side is equal to, and then when you expand this, we'll see it's 4c. 4cx cubed. C is equal to 3. Okay, now next. Okay, if we put x as naught in, we'll get d straight away, won't we? So why don't we put x equals naught in? Equate constants, in other words. Minus 6 is equal to, this is naught, 3d, so that tells us that d is equal to minus 2. Okay, d is equal to minus 2, move the 3 underneath there. So we can write that answer then, cx plus d. Cx is 3 plus d, which is minus 2 lots of over the 4x squared minus 1. What was it on top? 2x plus 3. That's fine. Now part C then. So we've done that, and we've got that, and now we can do this integration. So C, I'm going to label that I. Okay, so let's see what we get then. Okay, part C. I is equal to... So I'm going to copy and paste it. Save me writing it out. Or I'll just drag it actually down. And we'll work with this then, part of the problem. Let's have a look at this. Okay, now that's equal to the integral between 1 and 2 of cx 3x minus now they put 2x plus 3 in a bracket for some reason. I don't see any reason why that should be the case, so let's just expand the bracket. Minus 6 over 4x squared minus 1 dx. Now if you see when you differentiate this you get 8x. Oh, yeah. Okay, so that's equal to the integral between 1 and 2 of 3x minus, now this I'm going to put as a half 8x over 4x squared minus 1, because that's our 4x, isn't it, with a minus. But the reason I wanted an 8 was because this differentiates to 8x, doesn't it, when we differentiate the bottom. So this is a log form. And then it's minus 6 over this. And if we go to the top... oh, hang on, we got this 2x plus 3, haven't we? So that's why they did it. So I need to just retrace my steps. So this would be minus 2x. So I am going to write that. It's minus 2. Sorry about that. I didn't pick up the part A, which I'm going to do now, because it's all done for you in the structure of the question. So it's minus 2 lots of. Now, is 2x plus 3 over that can be replaced by this answer here. Okay, good. So that would be minus 2 lots of this. So that would be 4 of these minus 2 of those. Minus 4 of these, then, because we're doubling. 2x minus 1. Minus 2 times minus 1 is plus 2 over 2x plus 1. There we go. Okay, dx. That's good. So let's work it out then. So integration then, raise the power, 3x squared over 2 minus, now this is a log of 2x minus 1. When we differentiate this in our mind's eye, 1 over something, which was what we wanted, multiplied by the something differentiated. This differentiates to 2, we wanted 4, so we need a 2 there, don't we? Similarly, the next one is log of 2x plus 1. This differentiates to 1 over the something multiplied by the something differentiated, which is 2, which comes out naturally. So that's fine. We integrate this between 2 and 1. So this is equal to then. Top value, put 2 in. 2 squared is 4. 4 over 2 is 2. 3 2s are 6. Minus 2 ln. 2 in here. 4 minus 1 is 3. Plus ln 2 in here, 5. That's the top value then. Minus the bottom value. 3, 1 squared, so it's 3 over 2, isn't it? Minus 2. 2 ones are 2, minus 1 is 1, log 1 is 0. So that can go, that's 0. And then the last one is plus log 1 in here, log 3. Okay, close bracket, so that equals then 6 is 12 over 2 minus 3 over 2 is 9 over 2 minus 2 log 3 minus another log 3 is minus 3 log 3 plus ln 5, which is 9 over 2 plus ln 5 minus ln 27, which is equal to then 9 over 2 plus ln of 5 over 27 minus, you divide, don't you? So P is equal to 9 over 2 and Q is equal to 5 over 27.